So good afternoon, all of you. So in the last class, we have finished pointing vector, right? And now let's move ahead. Next one, that is wave impedance. What is the next topic? Wave impedance, and it is noted by Z. Wave impedance, it is noted by Z. What is the definition? In AC, we have learned impedance means what? Resistance offered by components to alternating current. Yes. Similarly, here wave impedance means what? The opposition offered by medium to the propagation of wave is called wave impedance. Yes. So opposition offered by medium to the propagation of wave. Okay. Opposition offered by medium to the propagation of wave is called wave impedance. Now this wave impedance Z is given by E by H, and this is equal to under root of mu by epsilon, and we know what is mu value? Mu r into mu naught divided by epsilon r into epsilon naught. Yes. Why we are getting like this? Because this E is equal to C into B, already we know. Yes. And H also we know. Yes, what is H value? B by mu naught. Yes. So that's why we have replaced this mu by epsilon, and that is mu r by epsilon r into mu naught by epsilon naught. Right? Okay. Right? So next one. For vacuum or free space, for vacuum or free space, Z is equal to under root of mu naught by epsilon naught, which is equal to 376.6 ohm. If you will substitute epsilon naught value, we know epsilon naught value. Yes, no? Epsilon naught value is what? 8.85 into 10 to the power minus 12. Yes, mu naught value also you know. Mu naught value is what? 4.10 to the power minus 7. If we will substitute this, we will get this value. Okay. And for a conducting medium, Z is equal to mu omega by sigma, where omega is angular frequency of incident electromagnetic wave, and sigma is what? Conductivity. of medium, whereas mu is what? Mu is permeability. Okay, permeability of medium, right? So this is what about impedance. Okay, so note down first all these things. Let's move ahead. Now, note point. For higher frequencies, for higher frequencies, JD is larger, that is impedance is larger, and hence electromagnetic wave is reflected. Okay, and therefore good conductors are good reflectors. Next note point, for perfect conductor, for perfect conductor, sigma is very high. Sigma is conductivity. Okay, sigma is very high because for conductors conductivity is always very high, so sigma is very high, hence JD is 0. Okay, and for transparent medium, refractive index n is equal to impedance in free space divided by impedance in medium. Okay, this is another formula for refractive index, impedance in free space by impedance in medium. Next one, as already I have told you, E by B is equal to E by mu naught H. B by mu naught is equal to H, same only. Yes. So B is equal to mu naught H. And that's why 1 by mu naught into mu naught by epsilon naught, which is equal to, or that implies E by B is equal to 1 by under root mu naught epsilon naught, which is equal to C, and therefore E is equal to B into C, or C is equal to E by B. This already we have learned before. That's why even here also the same thing, E by H we have replaced with this mu by epsilon under root. Okay, this is the reference for that part. Already we know this, just note down. Now let's move ahead. Now see the next topic, that is average energy density of electromagnetic waves. Right? What is the topic? Average energy density of electromagnetic waves. Now, electromagnetic wave consists of electric field as well as magnetic field, and that's why average energy density due to the electric field is equal to half epsilon naught E square. Okay, this is due to electric field. This already we have learned in electrostatic chapter. Yes, average energy density. Next one, due to magnetic field, maybe in electromagnetic induction you have learned this, that is half into b square by mu naught. This is what the average energy density due to the magnetic field. Due to MF I am writing, that is what magnetic field. Now total energy I want, total average energy density I can say. So total U is equal to UE plus UB, and that is equal to half epsilon naught E square plus B square by 2 mu naught. This is what total average energy density, right? Now this E and B, we know this E is nothing but ERMS, yes, and B is equal to BRMS. So U is equal to half epsilon naught ERMS whole square plus BRMS whole square divided by 2 mu naught. Okay. Now ERMS and BRMS values. ERMS is equal to E naught by root 2 and BRMS is equal to B naught by root 2. So therefore, now this energy U is equal to, I'm writing with this U, small u, okay. So that is equal to half epsilon naught. This ERMS square is there, no? So at that place, U naught by root 2. So U naught by root 2 whole square means U naught square by 2 plus half into B naught square divided by 2 into this mu naught, right? Yes, no? So what we are getting this U value now? 1 by 4 epsilon naught E naught square plus 1 by 4 B naught square by mu naught. This is what average, total average energy density in terms of peak value of electric field and peak value of magnetic field. Okay. Now, what we have seen, here you see average. So I'm writing like this. UE average should be equal to UB average. Means what? Average energy density due to electric field should be equal to average energy density due to magnetic field. Yes. And therefore, UE is equal to what we have, 1 by 4 epsilon naught E square should be equal to 1 by 4 epsilon naught. E value I am substituting. What is this? E square value. E square value what we have, or E naught square value what we have, we know C is equal to E naught by B naught. Yes, no? So E naught is equal to C into B naught. So here if I'm substituting C into B naught and doing square, what I'm getting C? 1 by 4 epsilon naught C square B naught square. Yes? Yes, no? And this C square is equal to what? 1 by 4 epsilon naught. This C square is nothing but 1 by under root mu naught epsilon naught whole square. That's why square and this square root will get cancelled. So 1 by mu naught epsilon naught into B naught square. This epsilon naught cancel. And that's why 1 by 4 B naught square by mu naught. This is what UE, and that is equal to UB average. Understood? Got it? Clarity? Clear? Or shall I explain one more time? Understood? Clear. Okay. Or is it necessary to explain again? You can drop a message. Shall I explain again or understood this part? Understood. Okay. Nothing to do. See here. What we have to prove, that this average energy density of electric field should be equal to average energy density for magnetic field. So what I did, I have taken this formula 1 by 4 epsilon naught E naught square. Then this E naught is there now. I have replaced with B naught into C. And then C square, we got C square B naught square. This C is nothing but under root 1 by under root mu naught epsilon naught. So C square is 1 by mu naught epsilon naught. Cancel karo. You will get this, which is equal to this part. Yes, no? Okay. So note down. So this is what average energy density for electric field and magnetic field, both are equal. Okay. Now, see here. So now average energy density of electromagnetic wave, that is U, is equal to UE plus UB. So I can write like this 2 times UE, or it is also equal to 2 times UB. Yes, no? Two times UV is equal to 2 times UV. Why? Because UV is equal to UV we have proved. So at the place of UV, you replace UV, then UV plus UV is equal to UV. In the second time you replace UV with UV, UV plus UV, you will get 2 UV. Yes, and therefore UV is equal to 2 into this UV value already you know. What is that value? 1 by 4, 1 by 4 epsilon naught E square, and this is equal to what? Half epsilon naught E square, and also U is equal to 2 times UB, which is equal to 2 into 1 by 4 B naught square. Here either you take E naught, you take B naught square by mu naught square. This 2, here only mu naught, no? Yes, no? Only mu naught here. So this 2 and this 2 is getting cancelled, and you are getting mu naught square by 2 mu naught, and therefore U is equal to half epsilon naught E square. E naught square is also equal to half B naught square mu naught. Yes, B naught square mu naught. That is what? Average energy density of the electromagnetic wave in terms of peak electric field and peak magnetic field. Okay, right? So note down this also. So from this we can conclude that half the energy of an electromagnetic wave contained in electric field and half the energy in magnetic field. Okay, so let's move ahead. Now next topic, that is intensity of electromagnetic wave. Okay, what is the next topic? Intensity, right? So first of all, intensity definition. What is the definition? Energy crossing per second. Energy crossing per second per unit area of surface perpendicular to the direction of propagation of wave. Same like how we learn in wave optics, direction of propagation of wave. Okay, so now first of all, what I am doing, see, intensity I is equal to energy per unit time per unit area. This is basic formula which we have, but now you see we have energy density. Energy density we have, that is small u. Okay, we know energy density is small u. So energy density means what? U, which is equal to capital U by phi. Yes, no? And therefore, can I write like this? U is equal to small u into phi, where phi is what here? Volume. That's why I'm writing in capital letter. Okay, right? So this U is what? Energy. Capital U is energy, small u is energy density. Now, this volume V, I can write like this: area into length, and this area into this length I can replace velocity into time. So I'm writing small time c into delta t. Okay, right? Or else if you want, you can write t also for our understanding. Velocity into time, because this c is equal to L by t. Hai na? Velocity is equal to length by time. And now therefore I is equal to u value. What you will get now? Let's replace this capital U value, small u into A into C into T, and let's replace this. So you will get small u into A into C into T divided by T into A. So this T and this T will get cancelled. This A and this A will also get cancelled. So you will get U into C. And what is U value? What is U value? You know, 1 by 2 epsilon naught E square into C. Yes. Or this is also equal to V naught square by 2 mu naught into C. Yes. Yes, no. Right. This is E naught, right? Okay. And if you want to replace in terms of RMS, then what you will get, right? Epsilon naught E RMS square into C, because this E naught by root 2 is 1 ERMS. E naught by root 2 into E naught by root 2 is E naught square by 2, and that's why ERMS square, which is also equal to here BRMS square divided by mu naught into C. So this is what your intensity formulas you are getting like this. Yes, clear, understood. So note down. Understood. Any doubt you can ask. Okay. And one more point I will write here, that is the intensity of electromagnetic radiation from an isotropic point source at a distance r. For example, if this is the point source, and this is what light emitted from this point source in all possible directions. Okay. then in this case intensity I is equal to power P divided by 4 pi r square. So this intensity is nothing but power per unit area. Even from this also you see here only I is equal to U by T into area is there now. Yes. So this U by T is nothing but energy by time now. So intensity is equal to power per unit area I can write now. Same thing here also. Just to this sphere is there no point source. And that's why whatever the radius I am taking, if this is R, this area is what 4 pi r square. And that's why I'm getting P by 4 pi r square. That is what intensity. Okay. In this case. Understood? Clear? So note down wherever the necessary points you want. If you want these points, you can write this side also. Clear? So note down now. Just finished. So we will stop here. Okay.